This is Team Vocoder. I'm Dustin.
Joe.
I'm James.
And this is our project that we made. It's a vocoder, a 12-channel analog vocoder. So the concept of how a vocoder works is you have a carrier signal in here and a modulator signal in here. Both the carrier and the modulator signal are each separately sent through a filter bank of 12 identical filters. So they're both being filtered in the same manner.
So as Dustin pointed out on the physical device, we are using a 12-channel device. And so obviously with that, there's an analysis for each filter. This is what was used on MATLAB. We used MATLAB, National Instruments Multisim, both as ways to simulate the filter characteristics that we would get. So here from Music from Outer Space, we have a recommended gain and Q factor for a given frequency. And then as we keep going, this is the code that we used. And so we're going to get a transfer function and a Bode plot for each center frequency. And so when those are combined and put on one plot together, we have this right here. So we can see how on this magnitude plot down here, we've arranged from 10 to the fourth hertz frequency wise, and we can see how our frequency spectrum lies on. And this is ideal. This is without any kind of real world effects. So this is the ideal for what the filters should look like based on their transfer functions. So you have the low pass filter on the left, followed by the 10 band pass, and the high pass filter on the right. And it kind of shows how each has its own bucket of frequencies.
This creates, essentially, you could think of it as like 12 copies of the original with only a small part of the frequency remaining. So the modulator signal, each of the 12 outputs from the filters are full wave rectified and then sent through a very low, like 10 hertz low pass filter to create what's called an envelope of the signal. And this is essentially just kind of an outline of the pattern of the signal. This output, so we have 12 of them, they're all different. Each of those outputs are multiplied by the output of the same filtered carrier signal. So then at the output of the first filter of the carrier signal and then the first envelope of the modulator signal are multiplied together, and then the second filter, third filter, all the way through to the 12th filter. And then once we have our 12 new signals from these multiplications, those are all added back together, and that is our vocoded output. So on this front panel, we can switch to mic or line level. So this mic will just add amplification to whatever is plugged in, just additional amplification. We have that for both of these. The levels can be adjusted here and here. And then if you don't have an audio source for the carrier, like a piano or a synth, this is an internal square wave oscillator. So you control the frequency here, the pulse width here, and then the level here. We also have onboard white and pink noise, which can be toggled back and forth here. The idea of noise being added in is noise adds higher frequency into the audio so that you can hear things like S's and T's, and just kind of helps fill out the sound a little bit. And you can control the level of mix you want of that. And then we've got, if you want to mix in some of the original audio from the carrier or modulator, you can do that here. And then sibilance is just it's just kind of some high-end white noise to help with S's and T's, things like that. And then the final output is here. Okay, so this is what it sounds like. We're going through all the vowels and then the alphabet. This is a pre-recorded message, and I'll mess with the frequency and some other stuff so you can hear what that sounds like. while we're doing this.
So this is our Vocoder project. Thanks for watching.